You type a prompt. Seconds later, a stunning image appears. Or a complex piece of code. A new reality, conjured seemingly from thin air. We marvel at the speed, the intelligence, the sheer digital magic of artificial intelligence. But what if every click, every generated word, every pixel on your screen was actually drinking from a hidden, global tap? A tap that, even as you watch, pulls thousands, millions of liters from our most vital resource, fresh water. Most of us imagine AI's environmental footprint is confined to the humming servers of data centers, cooled by vast quantities of water. But that's where everyone is wrong. The true thirst of artificial intelligence extends far beyond, tapping into invisible aquifers across its entire global supply chain. When we consider AI's water consumption, our minds typically go straight to the massive data centers. And rightly so. These digital brains get incredibly hot, requiring sophisticated cooling systems, many of which use evaporative cooling. A typical large data center can consume millions of liters of water per day, comparable to a small town. Companies are increasingly aware of this, investing in water-positive goals, using recycled water, or employing adiabatic cooling. They track these numbers carefully. But what if the visible water use at the data center, while substantial, is merely the most obvious drain? What if the real story, the much larger environmental cost, begins long before the servers are even powered on? The journey of AI begins not in a data center, but in a fabrication plant, a fab, where silicon chips are born. To create the minuscule, intricate circuits of an AI chip, manufacturers use ultra-pure water in staggering quantities. This isn't just tap water. It undergoes intense filtration, removing every impurity that could compromise the delicate electronics. It's used for rinsing wafers after each etching step, for cooling machinery, and as a critical component in chemical solutions. Think of it like this. Manufacturing a single advanced GPU, the brain of today's AI, can require thousands of liters of this hyper-clean water. This consumption is often hidden within industrial water accounts, far from public scrutiny, yet it's the very foundation upon which AI is built. Next, consider the immense energy demand. Every step of AI's life cycle, from mining raw materials to chip fabrication to powering data centers for training and inference, requires electricity. And electricity generation, contrary to common belief, is incredibly water-intensive. Thermal power plants, whether fueled by coal, natural gas, or nuclear energy, use colossal amounts of water for cooling their steam turbines. Even hydroelectric dams, while often considered green, cause significant evaporative losses from their vast reservoirs. So, even if your AI data center claims to use clean energy, that energy source itself has a massive, often invisible, water footprint, potentially hundreds or thousands of kilometers away from the data center itself. Before a single chip can be manufactured, the raw materials must be extracted from the earth. AI hardware relies on a complex cocktail of elements: silicon, copper, gold, lithium, and rare earth minerals. Mining these resources is a profoundly water-intensive activity. Water is used to separate valuable minerals from ore, to suppress dust, and to transport slurry. The chemicals used in processing can contaminate local water sources, making them unusable. This means that the quest for faster, smarter AI often places immense pressure on distant ecosystems and communities, particularly in regions already grappling with water scarcity, extracting their vital resources long before this smart part of AI even comes into existence. So, if the data center is a visible tap, the global supply chain of AI is like a vast, interconnected shadow aquifer flowing beneath the surface of our awareness. Each time you interact with AI, you are metaphorically tapping into this unseen network. From the initial prompt to the final output, every calculation, every data point processed, has roots extending back to a factory pouring water over silicon wafers, to a power plant cooling its turbines, to a mine excavating vital metals. It's a distributed, invisible thirst, drawing from local rivers, lakes, and groundwater reserves across the globe, all to power the digital intelligence we've come to rely upon. The implications of this invisible water footprint are profound. As AI adoption accelerates globally, its demand for water will only intensify. This isn't just an abstract environmental concern, It directly exacerbates global water stress. In regions already facing droughts, where water is crucial for agriculture, for drinking, and for local ecosystems, AI's upstream consumption creates a direct competition for this vital resource. The hidden incentives driving this are clear: prioritize speed, performance, and cost, often overlooking the distributed environmental cost. It forces a difficult trade-off: innovation at what cost to our shared planetary resources and vulnerable communities? Understanding this vast, invisible water footprint is the first crucial step. The path forward demands transparency and accountability across the entire AI supply chain. We need innovation not just in AI's capabilities, but in its very foundation. Developing less water-intensive chip manufacturing processes, prioritizing renewable energy sources with minimal water impact, and rethinking the materials used in its hardware. This isn't about halting progress, but about conscious consumption. It's about building a truly sustainable artificial intelligence, one where its brilliance doesn't inadvertently deepen the global water crisis. The invisible aquifers are real, and recognizing their existence is how we begin to protect them.